All right. Can everybody that is on hear me and see my screen?
Yep.
Thank you. Okay, so we still have a couple of minutes before we get started here. I'll pause, I'll leave this up, and we'll get started probably shortly after the hour when the number of participants coming in slows down drastically. Welcome, welcome. We have, 8 people here now. We are expecting about 50, so we'll probably wait just another minute or two. I know that it's a little bit early for some of the people that are joining us from the West Coast. So thank you for being here, being on time. If you would grab the link here, the bit.ly link for the slides, that'll go to a folder that has all 3 sets of slides for today. And then once you're there, you can use that to click on the Q&A doc as well as the survey. All right, I was going to put the links in the chat, but I see that Helen is ahead of me. Thank you, Helen. I appreciate that. Um, shall we go ahead and get started? Sure. Why don't we do that? So thank you for coming to this containers training. My name is Adam Lavely. I am on the Programming Environments and Models team at NERSC. I spend a fair amount of my time doing container type things and trying to make sure that we get good performance within containers and using containers on our system. So let's run through some things for today. First of all, I want to be very clear about what we're going to be doing today. Right, today is going to be a very general training. We're going to talk about the very basics of containers and be able to get somebody with no experience up and running. And we are going to have some hands-on exercises. So the types of things that we're going to be talking about today are container files, which are also called Docker files. I'll get into that later. Building the containers, pulling containers from registry, using our containers on the system both interactively as well as being able to submit jobs using these containers. And then I do have kind of some more advanced ways to use containers, just introductions to these. Really, this is to give you an idea of what's going on so that if this is something that is useful for you, that you can go and learn either from our documentation or from some of our other training resources, how to use these things. So again, today is just about the basics. You should be able to go from 0 to, well, maybe not quite hero, but pretty close. But we do have some super awesome things, super awesome ways to use containers at NERSC that will kind of point you in the right direction if those are things that interest you. Now, I also want to talk a little bit about what today is not. Right, so it was pointed out to me a little bit too late, and I do apologize for this, that I didn't put any prerequisites in the sign up for the course. So I'm not really talking about general HPC practices, how to submit jobs. I do in the slides have a couple of links to those things. And so if you aren't familiar with this today, hopefully you can copy and paste, but hopefully there's enough information for you to gather what you need to get started beyond this. We're also not going to be doing a deep dive into any of the container runtimes. We're just talking about how to use these and not really how they work. The other thing is that all the things we're doing here are fairly generic, right? There's really going to be nothing that lines up with probably any individual's full needs. If you do have needs like this, feel free to submit a ticket, and the nurse consultants as well as the other staff can definitely help you out. We do have these exercises that are there. And because of the amount of people that are here, I'd appreciate if we could keep towards just those exercises during the time and not trying to get help on your own container things if you're having issues. Again, submit a ticket. We can get you the help that you need, but now is not the time for that. And as I mentioned before, I'm going to introduce some of the kind of advanced topics that you can do with containers and point to resources. But really the goal for you coming out of this should not be able to use spin or be able to make my container into a Jupyter Hub kernel, right? These are things that you can do, and we give you enough to kind of get started on that, but those will be things that you'll have to work on outside of this training. And I also, just kind of as a housekeeping thing, I had originally put down that this is 4 hours. After going through the material, practicing with some of the staff members, I think that we're going to be out of here in a little bit closer to 3 hours. And so that's why when the email came out that it was listed for 3 hours. So I just want you to be aware that, I will have time. I can stick around and help people work through the exercises beyond the calendar invite time. But I do anticipate that we'll be able to get through the course material in 3 hours. All right, so the agenda for today, we're going to have 3 sessions. And after the first session and second session each, we're going to have some hands-on exercises. So the first session is really to get you started and also running containers, right? We'll pull from outside. And so the containers that we'll use are not going to be our own. So we'll be able to actually get on and get running, right? And if this is enough for you and you don't need to know the rest, by all means, stick around and watch. But, this should be enough to get a lot of people going. The second session is really more about how to build containers and how to make sure that the containers are going to work well on Perlmutter. And so our hands-on exercise is going to be a little bit more complicated, right? We're going to build an MPI container and do a hello world using MPI, using the system MPI that we have, not the MPI that we build in the container. And so this, again, is a little bit more complicated, but hopefully it'll be something that's useful for a lot of people. And then the third session, we have so the goal after that second session is to have the exercise where we're doing the things that I was just talking about right after those things. And then the third session is really going to be kind of a jumble of odds and ends, some tips and tricks for how to make sure that things are working well. If you do have issues, especially with Podman HPC on Perlmutter, some ways that you can mitigate some of those things, and then some of the introduction to the more advanced topics. We'll also have a little wrap up at the end where I tell you how to get a little bit more help and encourage you to submit the survey. But again, I would appreciate if you'd be thinking about that survey as we go through. Well, I apologize. I think that we have somebody that is, okay. All right, and now the other question that I need you to be thinking about today is how you interact. So we have a Google document. Helen has posted this in the chat. If you've grabbed the slides already, there's a link to it there. And we have several staff members that are going to be around to answer questions in there as I'm giving the presentation. And then also during the exercise section. So I apologize, I can only stare at one screen at a time, but I'll look at it at that point. I've also set up Zoom today so that we have some breakout rooms for the exercise period. And so if you have a question, you can ask it in the Google document, and one of the NERSC staff members might suggest that you jump into one of the Zoom breakout rooms. I've left those open so that you and the staff member can say, we're going to go to breakout room number 2. And you'll be able to share your screen and discuss whatever needs to be discussed. So I hope that this is going to be a way that we can, even though everything is virtual and we only have a few staff members around, that you will be able to get some personalized help if you need it. And then again, please fill out the questionnaire at the end. This helps us both figure out what we need to be doing differently for training, as well as if there are new trainings that we need to be thinking about doing in the future. Okay, with that, we're going to get started on some actual container material. So at first, I want to talk about what a container is. There's a lot of different definitions out there. I think that the reality is that, for different people, for the way that they use them, there's many that are going to be considered correct. The answer that I like for what a container is an encapsulated software environment that runs using a separate Linux kernel. So when I build my container, and we'll talk about building later, I'm going to build it and it's going to have its own Linux kernel in there. But then when I run it, we're actually going to be running on the system itself. So the encapsulated software part of this is that you get to package the software as well as the data, if that's something important to you, that you think is meaningful and relevant for your project together. This is a great thing for reproducibility, for portability, as well as consistency. The other thing that I really like doing with containers is being able to, once I've worked on something, pass that off easily to somebody else without giving them, my chicken scratch scrawl for notes for how to compile and build everything. The container itself is going to run using a container runtime. There's a whole lot of different runtimes. We'll talk about this in a couple of slides. This is not really important for us right now, right? We're just going to use the runtimes, but it is important for what a container is. And then as this container is running, it's going to be using the host machine's Linux kernel underneath. So if there are, say, 3 containers running on a node, there's really only going to be that host system Linux kernel running. And so that's going to be much more efficient than if each of those individual containers were all running their own kernel, like all had some sort of completely isolated space that they had to do all the compute for. So when people talk about containers, there's a lot of related topics that are out there that, most of them have to do with something. These are the ones that are probably the most confusing. And I want to talk specifically about a few of these because we're going to be discussing them today, but then the rest more because it's good to know when you start to go out into the world and do container things on your own. So first off, we have this thing called the Open Container Initiative. So this is a standards body. And, over the past, I don't know, maybe 5 years, give or take, there has been a large push for standardization across all the different container engines that are commonly used. And this makes it very easy because then if something is, working for Podman or Podman HPC, you can be fairly confident that it's going to work if you run it on another system with Docker. And so this really helps with the portability aspect of things. But the OCI standards are also very useful because it allows us to, like you, for example, to look at, say, the Docker documentation. And most of that is going to be perfectly relevant for using with Podman HPC. The little bit that won't are going to be some of the edge use case type things. And so this has really helped, I think, as containers have become larger and larger, and in a more important part of computing, this has really helped to make sure that it's easy to grow. Okay, so I talked about what a container is before. Something else that's kind of similar to a container is a virtual machine. And with a virtual machine, it's actually an emulation of the entire computer itself. And there's some sort of hypervisor that's running that allows you to access the hardware. So you have your own Linux or whatever kernel running, right? It could be Linux kernel. It doesn't have to be. But this is going to be a little bit more isolated from the host machine as well as from any of the other virtual machines that are that are running at the same time. There's a little bit more overhead that's associated with these, and it's kind of a different setup for the way that these are typically run than containers. But I do want to just be clear about the kind of differences between containers and virtual machines. We're going to be running all of our containers using a job scheduler, and we happen to be using Slurm. A lot of other places that use containers use a container orchestrator. So Kubernetes is a standard for container orchestration. So we will not be using any Kubernetes here today, but when people talk about containers, they often do talk about orchestration and Kubernetes like OpenShift or Rancher. This is another thing that is fairly standardized now. There's a governing body for this. Again, very useful, just not necessarily something that we're going to be using with containers on HPC systems. And finally, I mentioned that we are going to be submitting our containers as jobs. We're going to be interacting with our job scheduler, which happens to be Slurm on Perlmutter. And so this really just allocates resources for any job, and that job that we're going to be doing today is going to be a container. I apologize. I'm getting a little bit of feedback. Let me. Okay. Oops. So on this next slide, I don't think that I need to go into this in too much detail because you're at a container training. That means that you must see some importance in containers already. But if you were to try to explain why to use containers to somebody else, really this is some sort of functionality that has been set up specifically for the way that you want it, and that is for the most part going to be portable and fairly performant. So I'd like to tell just a quick story. Just last week, my group had a new postdoc start, and one of the things that I was helping her do at first is replicate some runs that were done about a month ago on Perlmutter. And it turns out that there were a couple of default system changes that had happened, or default module changes that had happened between when the codes were originally run and the compile notes were taken and when she was trying to run this last week. On any HPC system, there's going to be changes, there's going to be updates. Some of these might break your code, and so you have to recompile. You don't have to go through that, right? You could put your code into a container and have that be something that you always have access to, as long as that container runtime or the container can be run in a container runtime that's on the system. You don't have to worry about what's going on behind the scenes. So just a very brief anecdote that I experienced just this past week about why using containers would be far better than just our randomly copied Bash shell scripts. But that being said, there's a whole bunch of other things here. I'm not going to go through these, but I just want you to have them around. Some of these might be very important for you. Some of these might not at all be important for you. But the reason to use containers is that there's a whole bunch of reasons, and hopefully some of them are ones that are important for you. Okay, so when we talk about containers, there are containers that do a whole bunch of different things. Some of those things are in HPC, but a lot of those are not. And so we actually have built our containers, or our container runtimes here, and tried to optimize these for the different things that are important for HPC. So in HPC, we often are very sensitive to file system performance. Communication is often far more important for our applications than they are for applications that are running elsewhere. And then we also, our system, our Perlmutter vendor, the vendor has tuned some of our libraries, especially the MPI library, to get good performance. And so we want to be able to inject that at runtime and be able to get as good a performance as we're able to. And so, all these things are reasons why HPC applications need a little bit of tuning, a little bit of modification from, say, a standard container engine. And I've tried to denote that, as we go through with this little HPC superscript, just so that, if you're, say, poking around and doing something with Docker and realize, oh, this is different. This might be why, right? And I'm hoping that by pointing this out, you understand some of the work that we've done to make you successful and make your containers performant on our system, but then also understand as you go and do container type things other places with other container engines, that some of these might be a little bit unique to us. Okay, so getting into the containers that we have here at NERSC, right? So we have two different container runtimes. So we have Podman HPC. This is kind of our bread and butter. So Podman is a Red Hat project that is actually being pushed to be open source here. I think that was just announced about a month ago. But then we built a wrapper around that to be able to add in some of those HPC things that are important to us. So NERSC is very involved with the Podman team, as well as with putting together all the things for this wrapper around it. And the nice thing about Podman HPC is that you are able to build images as a regular user. And we'll get to that. That's going to be pretty much the focus of the second session today. But being able to build your own images so that on the system that you're on, you can build everything and test it right away is fantastic. Shifter is actually a different container engine that NERSC built from the bottom up, from scratch. I think it's about a decade old, I think. I'd have to go back through my notes and figure out when it first started being used. But it was built by NERSC at a time where the other container runtimes were not quite well enough developed to really address the HPC needs that we had. We have a lot of people at NERSC that use this, but it has not been adopted elsewhere. There are some other groups that have taken Shifter and put their own like modified sort different things, or built things like Shifter using Shifter as a template. But really Shifter, for the most part, I think NERSC is going to be about the only large-scale HPC place that you'll see this. As I mentioned with Podman HPC, Shifter is a little bit different. The images that you want have to be built elsewhere. So I build a lot of my images on my own personal laptops. I'll push to a registry and then I'll pull down. And so you just have an additional step. So I also want to point out that these are two container runtimes, but there are a whole bunch of different other ones, right? Docker is kind of the standard. Apptainer, Charlie Cloud, Singularity, these are container runtimes that you'll often hear talk about on other HPC systems. Containerd and runC are kind of a little bit lower level. These might actually be included in other container runtimes for specific things like the actual running, maybe not the building. But all these different application container runtimes might be available elsewhere. And because these are being built to be OCI compliant, the hope is that if you see some instructions for Docker or for Charlie Cloud, that with very minor modifications for the command that you actually call, right, using Shifter to run Shifter type things or Podman HPC, that you'll be able to do pretty much the exact same thing and translate between systems and container runtimes fairly easily. Okay, so that's a little bit about containers. Let's talk now about just the basics. Let's talk about how we're actually going to use containers. And as I go through this, I'm going to add more and more of the terminology in. And so what I would ask that you do is, pay attention as much as you can, but as soon as your eyes start glazing over, concentrate more on remembering what came before. And as you start to do these things, as we get into this, I'm sure that it'll be far easier for you to come back. So trying to make this as simple as possible to understand. We really have two steps that we're going to be doing. The first is getting a container image, and then the second is running the container. Now, when we get the container image, we can either build this ourselves or we can download one. When we run the container, we're going to use some program to actually run it. So all the rest of the slides here are really explaining this in more detail. So if you understand this, then you'll be able to copy and paste and maybe not fully understand all the examples that we're going through, but hopefully understand enough to be able to walk through it and develop your understanding as you go. I know that a lot of people are book learners. A lot of people are the people that actually have to do it to learn it. So however is going to fit best for you. Just know that you don't necessarily have to have a complete, right? There's not going to be a test. You don't have to have a complete understanding of all these things before you actually jump in and get going. Okay, so this is kind of my common container workflows diagram. So this is kind of specific to this training, right? So using the spin, using the Jupyter, these are very specific to this particular training. But when you share your container, you can do a lot of different things. So let's walk through this just a little bit. So we're gonna make a container file. And that container file, this is something that we'll talk about in detail in session 2, is going to tell us what all goes in that container. And then we're going to build the container, and then we're going to use the container. And at both of the steps along the way, with your container file and with your container, you have the ability to share this in different ways. And we'll talk about what those ways are. Now, when we're using our container, I mentioned before that you can also download things. And so there probably should be another arrow coming in to use your container from be able to download the container, then use that container. And we'll talk about that a little bit more too. But when we build our container and share our container, the containers that we would use from other people are just containers that they've shared. So I think that that's kind of included on here, even if you're not the person that is building the container from a container file that you have created. Okay, so the make a container, build a container, let's kind of dive into that with a little bit more detail here. So really, we're talking about building a container image. And we'll get to the details of the image versus the container in a few slides. But we're going to start with the container file. And this is, a file that just specifies everything that needs to go in the container. The base operating system, whatever additional libraries that we want to put in, we're going to download some code and build it. And then also putting things in the right place so that when I run the container, I have access to the things that I want to have access to. This is human readable. And when I say human readable, I mean that it's not in binary, right? So if you struggle when you look at build lines, it might not look readable to everybody, but it's not in a binary format. Like you can actually see that the text that's in it and not have a whole bunch of ones and zeros or different ASCII symbols. So again, we're going to specify the operating system. We're going to install whatever libraries, and we're going to get and compile whatever files. So once we have this container file, we're going to use an image builder. So that's a program that builds the image that we want from that container file. So image builders, these are typically a part of container images or container engines. And I'll get to that in a couple of slides, but they might also be a separate program. So here today, we're going to be using Podman HPC for our image builder. If you want to install Podman or Docker on your laptop to use as an image builder, that's a perfectly fine thing to do. Because all of these are going to be making OCI compliant images, you can make it with one container engine, host it in a repository, and then when you pull it from a registry, you'll be able to pull into the format that you need for your particular container runtime. All right, so our image builder then builds an image. And so that is a binary file that has everything that you put into it, right? The base OS, the application, whatever data you decided to include. And these are going to be something that are fairly large, but are very usable. So just a couple of quick notes. I am going to try to say container file the whole time. I do want to point out that these are very commonly called Docker files, right? Docker was the first container type engine runtime to be widely used. And so just because of history, just because of inertia, they're still very commonly called Docker files. Container files is a more generic term, but yeah, I might even slip up today and call them Docker files. I apologize for that. It's not meant to be confusing, but it just turns out that because Docker was so important to the development of containers overall and is still so widely used, that the nomenclature that's used there is still very widely used. Right, and then on the image side, we can store images in an image registry, and we'll talk much more about this in a few slides, right? So there's quite a few different registries that are available for both posting something to be public as well as posting something to be private. especially if you're willing to pay for the private things. So this is a way to share your images. And then also from anything that's public, you can pull any others that are available. So one of the things that we'll be doing in the second session today is pulling an image that I've built and then adding something to it. And I guess in the first session, we'll be pulling an image that I built and just running it. So again, the registries are important because that's the way that we share the images, but we can also share other things as well. So talking about sharing, let's look at what this looks like with a little bit more detail. So container files are incredibly small, right? These are just text files. You know, if you get one that is several hundred lines long, that's going to be a very long one. And so whatever you like to do with small files, you know, I Slack these back and forth with my coworkers quite regularly. We do push quite a bit into different GitLab and GitHub repositories so that people have access to it. But container files are something that you can, you know, copy from somebody else, start with that, build it, you know, add things to it, or build it from scratch yourself. There's no wrong way to do this. Really, because you have access to all the information about what's going in the container, it's very safe to play with container files. Container images are a little bit different, right? Somebody else can build an image and tell you that something is in it, but that's not quite right. Right? It might be a little something different. And hopefully that's, you know, not out of malice, but container images, you don't necessarily have the back or the container file for that to understand what's in it. You can interrogate them and figure things out, but container images are a little bit less safe to share. That being said, they're also very large, and so they're much harder to share. So on Perlmutter itself, you know, you can give and use give and take and pass images around if you like. You know, put them on different shared directories or place them in registries. Okay, so for registries, I do want to talk about a couple of different things. So really again, the point of the registries is to be able to put your images someplace that then it's accessible to you, other places, as well as to other people that you want to share with. And that might be the entire world. That might be just your research group. So NERSC does run a registry service. It's called Harbor, and it's located at registry.nersc.gov. If you put in a ticket, you can get access to that. And if your PI puts in a ticket for your project, you can have access to a project space. There are groups within Harbor so that once you have access to it, you know, anybody at NERSC can see a certain subset of containers. NERSC staff have a way that we can communicate with ourselves, and then also different teams and research groups that are set up. So if you have access to registry.nersc.gov to be able to use this, you can access this from any system, right? It's not just for use on Perlmutter. However, there is not any access for any non-NERSC users, right? You have to have the NERSC account to be able to ask for an account on registry. And then once you have the registry.nersc.gov account, then you have access to it. But there's no way to share with the wide world or share worldwide. Registry is great because, you know, we work with it all the time. We have some ability to keep things moving, and it's also nice to be able to have a space for your project. But there's some wonderful other things that are out there. You know, I do want to talk about Docker Hub. This is what we're going to be using today, just because I know that not all of you have accounts on registry.nersc.gov. So I think that with the standard account, you get one private registry, and the rest have to be public, and you can pay for more to be private. So there's also Quay.io that's out there that I know a lot of people at NERSC like to use. I have less experience with that myself, but I know that it works quite well just because we have so many people that are using it. Oh, I apologize. I did want to point out on Docker Hub that we do have a NERSC location where we've posted some things, specifically right now, a lot of our applications that we've built. And so you do have access to that. But, you know, there's a lot of other publicly available containers out there if you would like to go and look through. I also want to point out that there's a couple of other good places to look for. NVIDIA has been working with containers for quite a while now and putting out a whole bunch of different containers. They're very useful because it allows you to, or we find them very useful because it allows you to use older versions of the CUDA runtime if that's something that you need, right? So you might want CUDA 11. I don't know, because we're using CUDA 12 now. And so using containers is an excellent way to do that. And NVIDIA's containers we found that they've worked fairly well without too many changes. I do want to point out that if you're trying to make things as similar to Perlmutter as possible, you'll want to use SLES. So the OpenSUSE organization has a bunch of containers that are available. We use these quite regularly internally to NERSC and find these very helpful. I've mentioned a couple times now that you can just Google around and find things that other people have put out there. You hope that nobody is doing anything nefarious, but it's always a good idea to look at the container file and potentially even build that container yourself, right? You can say, hey, look, somebody has built this, they've taken the time, but I want to build it myself so that I know, right? I can go through the container file line by line and understand exactly what's in here. And then also GitHub and GitLab both have some nice tools for being able to host both the container, use some GitHub actions, and build containers and have those be readily available. So these are things to be thinking about as you build up what you do with containers, but maybe not necessarily things for you to dwell on today. Okay, so now the last kind of portion of my lecture side here is how to use your container. And this is going to be probably the most important, right? Even if you don't fully understand all the technical jargon that I've thrown at you, if you can walk through this is probably going to be what gets you up and going. And then as you get going, hopefully you kind of have a better understanding for the technical aspect of what's happening and what all it's called. But let's get on with this now. Okay, so from before, we have that image. And again, you can build it yourself. You can have it shared with you. You can pull this from a registry that we just talked about. And then we're going to use some sort of container engine. We're going to be using Podman HPC, which uses runc under the hood, but or Shifter to actually launch the containers. And so your container engine, we use Podman HPC. Every Podman HPC command starts with Podman HPC. So it's easy to understand which container engine you're using or which container runtime you're using. And then the container is actually the image that is running, right? I've talked all about containers before, and I probably should have been using the term image, but because this is kind of our standard nomenclature for how to talk about containers, there is a difference between an image and a container, but we generally just call everything containers. So that image that's running is likely going to have the application that you have built. You might include within it, some sort of help command so that you can see some instructions for running. And then also, so with our running container, right? So anything that is going to be saved in the container is an ephemeral file system, right? So that will not be there the next time around. I will show you how to link, how to mount places on Perlmutter so that you can read from storage that will stay there and write to storage that will stay there. But the container itself, without those links, anything that you say or do will vanish when the container is done running. Okay, so again, with the container images, the container engines, right? So these have the container runtime and the image builder. I've mentioned, Shifter, Apptainer, Podman, Docker, Charlie Cloud. Like all of these are built for a specific purpose, right? Some of them might be built for very similar purposes in HPC, for example, with Apptainer and Charlie Cloud and Shifter, but that they all have slightly different options, and the way that different HPC centers put them on their system or make them available to users might be slightly different as well. And so I just want people to be aware of the possibility for those differences, right? I've talked about OCI compliance and how things are supposed to be fairly easy to go back and forth, but there are going to be some nuanced things based on the container engine that you're using, as well as the way that a site has determined that they should be putting these together. All right, and then I also mentioned with the containers that you can volume mount in data. or a place for data to either read or to write. The other thing that this allows you to do is to link into the host system libraries. So we're going to be doing in the second session today, we're going to be linking with MPI. And so that will use the Cray optimized MPI that's been built specifically for Perlmutter rather than the MPitch that we will build into our container. So now let's actually do some of this stuff. Well, first we're going to look at how to do it, and then we'll have the exercise. So bear with me here. Okay. The way that we're going to pull containers is using a pull command. So podman HPC pull will pull an image from a registry. Now, one of the things that I want to point out here is that when you pull with something like podman HPC, the image that's stored in the registry is OCI compliant. And when we pull it, we're actually going to be putting it into a specific form for that container runtime. Some of those things are fairly standard. Some of those things are built to take advantage of, say, the specific file system that we have here on Perlmutter, and so are fairly specific to HPC needs or the needs of the center. So the images that are stored are going to be able to be used by any of the different runtimes, right? If you're using Docker on your host machine and Aptainer when you're at TAC, you'll still be able to pull those same images, but having them put into the right format for your particular runtime image is something that's done when you pull them down. So when you pull this, you're going to be pulling from some place, and that place will likely have a username, right? The person that put them there, the container name, in this case, it's CUDA, and then the tag or version number, right? So oftentimes for people's own things, the tag is really just going to be some number that iterates up as you figure out mistakes and correct things and add more functionality. Oftentimes when you're grabbing containers from someplace like NVIDIA, they will put some more information about the container itself into that tag and version number name thing that's here. So in this particular case, the version of CUDA that it's using, as well as the operating system and version of operating system that this container has. And so likely, if you pulled this right now, you could change 20.04 to 22.04 and be able to get, the exact same container that's built with a slightly newer version of Ubuntu. Okay, and so then when we do this pull, I talked before about how when you pull, it puts it into the format. It's Podman HPC is also going to automatically migrate this to Scratch. So when you download a container, just like anything on our system, the best file performance that you're going to have is on Scratch. And so when we pull, Podman HPC automatically pushes that to a space on Scratch so that you have access to it from all the compute nodes on some of the fastest the fastest file system that we have. So when we're pulling, I do want to point out that you can pull any public container. And if you are pulling a private container, you might need to log in, and there's a way to log in. You can look at our documentation, but then the username would be your username at that place. So you can pull private containers that you are the owner of onto our system or any other system. Okay, so then after you pull it, you might want to look at it. So here I just have a couple of images that I had built for a different training. These are not ones that I don't think that we're going to look at these today. But when you pull the images and view them, you'll be able to view anything that you have pulled. And sometimes, right, so let's say, for example, you've built a container that is built off of another container. So when you get started, you're actually going to have that original container that you built from there, as well as your new container. So yeah. Now, when we're going to be running jobs, we can run them on the login node, we can run jobs interactively on the batch nodes, or we can submit a job to the batch nodes. So on the login node, we're going to run this with the podman HPC run command. We're going to put in the --rm to help clean up everything when we're done. And then we give it the container name as well as the version number. So here the container name is called no lols, and the version number is 1.0. This is really, fairly basic as far as how to run. This is going to do whatever is at entry point. you might also have the ability, or so many containers have different executables that are in there. And so you can call the different executables, but we'll get into all that kind of once we get beyond the basics here. Okay, so that's how to do this on a login node. So if you've pulled the container down, you can run this. You can see what is happening on the login node. You can also run this on batch nodes. So you'll see that the first line that I have here is requesting a job. So we do that using salloc. And then we have a whole bunch of requirements for this request. So if you look at this and this doesn't make sense because you're new to HPC, I understand. Take a look at the documentation link that I have here. But for right now, just know that we have, we're grabbing this for a short period of time. We want to use just the CPU nodes, and we want to do this interactively. So this is just getting some compute resources made available to us. And then the next line is our actual Podman HPC line. And this is going to run once you're allocated a node here in this case. You'll notice that I have one $sign for things that you would type in when you're on Perlmutter, and the 2 here is when you're on the interactive job when this is started. So the other thing to note is that the run line here is the exact same as the run line when we're on the login node. Right. So when you're running this interactively, it's just on a different resource that we've had to request. So for submitting jobs, like we can submit these using a script, using SBatch. And again, if you're new to HPC and this looks like a whole bunch of Greek to you, I have the links to both our documentation as well as our sample submission scripts. But the important thing here is that we are, again, requesting resources.
Sorry about that. I went, so I don't know. Have you ever ordered?
Okay. Again, we're going to go out and request some resources, and then we're going to run our podman HPC command to run the container. And the 2 things to note here with our 2 previous, sorry, let me go back. With our 2 previous things here, whatever you're doing in the container will show up just right on the screen in front of you, right in the terminal. When we do this, so we don't have that terminal, right? This is a batch job that is running in the background. And so it's going to the, whatever we're doing will pop out with the .out file that we create here. You can also go to standard out if you don't include the output, and you might potentially have something in error as well. But this is generally what you'd want to do is set things up so that your job will run with some sort of output file. And then again, we're using the exact same command that we used when we did the job, or when we ran the container on the login node or with the batch nodes, right? So it's fairly easy to go between these. So Podman HPC, because we can build on Perlmutter, is probably the best place to get started. And the other things to kind of know, and these start to get a little bit more advanced, we are going to use MPI in the second session today, but the rest of these we're not going to go over in too much detail. But again, you can volume mount locations to make spots that you want available both to read into your container to be able to do as well as write out. And then also, I do want to point out that we do have a couple of different network protocols that we can use. If you had been using containers before and you're seeing some sort of slowdown with things like wget or git clone, you might think about changing the network protocol back to what it was. And then going down to things here below, these are some additional system functionality. Again, we'll talk about MPI in detail later. Giving it the ---- GPU allows your container to see the CUDA driver and tools that we have available. And there's some more of these. I'm going to just point you to the link here for the NERSC docs. We're going to get started with the MPI today. Know that there are other things out there as you start to try to figure out what you need to be doing for your container. Look through the flags that we have, look through our documentation, and hopefully it'll be fairly obvious which ones to use. Okay, so all of that was from was for Podman HPC. And again, I like to use Podman HPC because I can build it right on Perlmutter and test it right there. I don't have to push out to a registry and pull back. But Shifter is still fairly widely used. I want to go over basically the same exact things with Shifter. But yeah, I'm going to leave this here, or I will go through this more for your knowledge. I expect that today will mostly be Podman HPC, although I encourage you to try doing things with Shifter as well. So basically, let's just run through the same types of stuff for Shifter. So we have to get our image from Docker Hub. And so here I'm getting something. So this is actually from my account on Docker Hub. It's called Adams lolcow. I do want to point out, so I built this myself so that when I tell you don't go out and download random stuff, that you have some trust in this. However, this is built from a very standard container that used to be used commonly for trainings that I still love. The user that did this before, their username was godlovec, and you can look at the container file in the links that I have here. So that the only difference between what was done for the previous version and what I have here is that it just has a newer version of the Ubuntu operating system. So again, trust your sources. I'm not linking to somebody else's here, but I do want to point out that, this is not my work. I've really just copied this, created the container, and once I verified that things worked and that everything that went into the container is trustworthy enough to put on our system, I've made that available to us here. So we have that Shifter image pull. So again, this pulls the container, which is being stored in some OCI image, and puts it in the right Shifter format. And really, Shifter was built and still does quite well, improving file system performance. So the username, this happens to be my username. When you download this, you will still use my username because it's under my account. We have the container name and we have the version number. So I mentioned that, so with both Podman HPC and Shifter, you're able to view all the images. With Podman HPC, all the images are going to be your images. With Shifter, when you view them, you're going to be able to see all of the images. And so grep is going to be your best friend because there are tons and tons of images that you will show up. So here, grep for the name of the container, especially as you start to build your own containers and are naming them with your username, grep for your username. But grep is going to be your best friend to know what is available. Okay, so just like with Podman, we can run Shifter on the login nodes. With Shifter, we're going to use Shifter to actually start the container. We're going to put in the image, right? So we have to include the -- image, and then whatever that's going to be. And then we also are going to include entry point here. So if you set up your container to do something, so some container runtimes like Podman HPC will automatically do it. And some container runtimes like Shifter will do it if you tell it to by using the -- entry point. So you control this when you build this container. It's one of those slight differences between the two different runtimes, but this is something that we need to do. So with our lolcow, it gives you a little cow and it gives you a little saying that is sometimes meaningful, sometimes whimsical, often funny. So I really like this. This will be something that we'll do in the exercises. You'll have the opportunity to try to get this with using Podman HPC. But there are some different things to know, right? So first of all, our Shifter container here is a little bit different from Podman because Shifter requires you to run it as you, an individual user. Podman HPC is slightly different, and so that's why we can actually build containers on Perlmutter. But if your container is not configured in a way that allows a regular user to do whatever you're trying to do, then it might hang. So we have a couple of ways to get around this, understand what to do. But really, if there are some permissions issues such that something works in Podman HPC but not in Shifter, it's very likely an issue where something that you as a regular user in Shifter are trying to access but don't because it's assigned to root. Right, similar to Podman HPC, we can run an interactive job on the compute nodes. So really the only difference here, we have the salloc, right? So we're requesting some resources. We're actually, the request is going to be almost the exact same, except here we're going to give it the image name. And so Shifter does this, it preloads the image so that it's ready on all of the nodes that you are granted. And it's useful here. It's kind of the way that Shifter was built. And then once we're on it, we're going to use the exact same command as we used before, only because we've already preloaded the image, we don't have to give the image name here. So when you run this, right, with this particular, the lol cow, the cow and the joke will show up. If you see here, when we run this on the login node with Shifter, you will see this in color. There's not going to be any color available here or when we run this as a batch job. So just something to be aware of. All right, and then for our batch Shifter jobs, again, when we're requesting resources, these are all going to look the exact same as for Podman HPC. These are going to look very similar to our salloc on the previous slide. And just like with the salloc, we're going to give it the image to preload the image. And then we're going to make sure that, and then we're going to run using srun. And again, we're going to use Shifter with entry point to be able to do what we're trying to do. And so, for the most part, if you can run this interactively, you already have most of the salloc options ready to go. We're going to be, again, here, putting this into the .out file, right? It's not something that will pop up on your screen. And we do have to preload the image. So Shifter, just like Podman HPC, has some options that are good options to know. Mounting volumes is going to be something that is likely very important to be able to use data that you have elsewhere in Perlmutter and then save your output someplace. But there's, I'll leave this here. We'll get to a couple of places where you can see all the Shifter documentation where there's going to be even more than this. For today, we're not going to be using any of this, but it is important to know that there are options available. And really what these are things that we've built in to make it as easy as possible for you to have access to things that we think are important. And a part of this is also the modules, right? And so they're called modules. They're similar to the modules that you load, the LMOD modules, so like module load, program env, something, but they're not quite the same. We do have more information about all of these on the NERSC docs. mpitch is going to be the one that we use today, but some of the others are there for different things that you might be doing with containers. I would recommend, after you go through the training today, as you start to think about how you're going to apply containers to your own research, taking a look through some of these things. If you're confused, submit a ticket. We can either answer via ticket or set up a one-on-one or set something up during an office hour to make sure that you know the best way to move forward. But we do have a lot of things already available. Okay, so now it is coming up on, 1 o'clock my time. So we're going to start with some exercises. So in the examples that I gave, I used Shifter to do everything with the locale, right? So pull it, run it on a login node, run this interactively, and then run it as a batch job. And so now I'd like for you to try to do that same thing using Podman HPC. And if you have time, all the steps are already shown for Shifter, but try to go through those things. And we're going to come back here at, so 1:20 my time is 10:20 California time. I'm going to be turning off my video and sound. I might go and fill up my drink, but I'll be back. I'll be answering questions in the Q&A doc, as well as popping in and out of breakout rooms if we need that. What I'm going to do is in about maybe 15 minutes, I will pull up my terminal and walk through this process so that, if anybody is not having success moving forward, that they have the opportunity to kind of see this. So with that, I appreciate you listening to me lecture for the last hour or so. We're going to pause for the exercises. I'll be interacting over the next 15 minutes. I'll showcase some of this live in 15 minutes. And then in about 20 minutes at 10:20, we'll begin session 2. So thank you.
Oh, sweetie.
All right, so we are at 10:15, actually 10:16, I apologize. I'm going to run through some of this very quickly. I see that there are some good questions in the document. I appreciate that, and I appreciate the staff members that have been helping to answer those. We'll continue to use that throughout the rest of the session. And what I will do is at the end of the session, right, if there are, sorry, when I say session, I meant training. So continue to use this through both session 2 and session 3. And at the end of the training, if there are any unanswered questions, I will stick around and make sure that those get answered. So if there are unanswered ones and you don't wish to stick around, you could throw your email in there and I'll put the answer in there for anyone to see, but I can also email you directly. So let us go back. Oh boy, I am sharing with full screen, not sharing the. Let me figure out how to do this. Okay, I apologize. I'm going to stop sharing and then reshare shortly. And of course, I've lost. There we go. Sorry, okay. Am I coming through with the exercise solutions as well as a terminal window?
Yes.
Thanks, Helen. So I did not mention this, but I did throw the exercise solutions in the slide right after the exercise slide. So anybody who is scrolling around, I'm sure saw that. But yeah, let's just walk through this. And I do have a little legend here. For your awareness, I've tried to do this throughout the entire, throughout all the documents, but I definitely might have missed one or two. So I apologize. That's something that's a little bit new. But oh, here we go. So our first is just going to be the poll command. And as I saw in the chat, people do need to include the tag because that's how we, oh, I have already done this. So it skipped because it already exists. And again, so if you do this again, you will likely see the same thing. I apologize that I'm not able to show you what it'll look like straight away. But we can run this. So I'm currently on login node 18. So we can run this directly on this particular login node. And should have put a shorter name so that I could type it a little faster. Whoops. I missed one of my minus signs here. There we go. Oh, that's one of the longer ones that I've seen. Fantastic. So we see our little lolcow come up with something that is less than whimsical this time, but most of them are lols. We can also run the same thing on one of the compute nodes interactively. So we use the salloc command for this. I'm going to do time just, if I can type, thank you. I'll just do maybe 2 because this clearly won't take very long. And then QoS interactive. So it'll probably take just a couple of seconds to get access to the resources. Fantastic. And then we're actually going to use the exact same command that we had before. I will get my 2 minus signs in this time, of course. And all right. That's a nice lull. At least how things have been going lately. Anyway, so that's running on the interactive node, and we do have to remember to exit out of that, out of our interactive job there. So I am looking at the time. We're definitely kind of coming into things. I believe based on the questions that came in, that, and as well as you guys having the solutions here, that we're probably good. In our next set of exercises, we will walk through the job submissions as well, in case anybody is interested in that with a little bit more detail. But again, I have both the how to do this for Podman HPC as well as for Shifter. Although I'm pretty sure that the slides had all of the Shifter stuff already ready to go. I think the Podman HPC, I did not use this particular example. The goal is hopefully to have people try to figure out what to do, and especially having the